Customer test requests often exhibit similarities at first, but tend to differ in detail. We like to receive the material up front to get accustomed to it with pre-trials. Ideally, the customers are present during the testing. Normally, this is the case, and it gives us the ideal conditions to find the best solutions for the customers and their sorting tasks. With the first test center, we already decided to set up a processing line with industrial scale dimensions. We have stuck with this approach. We focused accordingly on a very flexible process sequence. This was completed with a recirculation flow option for the test material in order to optimize the identification of the right parameters and settings. The aim of a customer test at STEINERT is generally to develop the right process in accordance with the input material and sorting target. The initial discussion is used to explain ideas and make suggestions on how to proceed. After testing, the results are discussed to create transparency in this type of consulting. The feed hopper already demonstrates that we are working at an industrial scale. The test material is introduced in batches of 0.5 to 2 cubic meters at a time. These quantities ensure that we generate reliable results on the solution that we are recommending to our customers. The material amount for a test mainly depends on specific material parameters. The processing line is equipped with different magnetic separators. These vary in material removal method, either pickup or overfed, and with regards to the magnetic field strength. This provides a choice depending on the requirement between quality of magnetic product and the extent of the ferrous removal. After the ferrous removal, a lot of input materials are subject to a non-ferrous metal separation step. For this, we use non-ferrous separators, also called eddy current separators. We, of course, implemented the most recent design with a number of variable parameters. In testing, the system is chosen according to the particle size range of the input material. The product of such a non-ferrous separation is a mixture which, depending on the input, consists of aluminium, copper, brass, zinc, and other non-ferrous metals. In addition to the magnetic sorting systems, the second main group of products are the sensor-based sorters. We offer machines equipped with a single sensor for material recognition. Furthermore, we have been focusing on a combination of multiple sensors over the past 10 years, and we advanced to a system that combines up to 4 sensors. We call this a combined sorting system, or KSS. The abbreviation is derived from its German name. With this, we're able to solve numerous sorting tasks with high efficiency and flexibility. The interface on the control has been designed so that it is almost self-explanatory, and especially the sort program selection can be designed individually with program name and image according to each customer. The system has room for 60 completely independent sort programs. It can be used for pre-concentration of special material groups or properties, up to the generation of high-end products. The majority of stainless steel items will report to the rest fraction of a non-ferrous separation. From this, it can be sorted into a concentrate by the means of sensor sorting. Depending on the combination of sensors in a KSS, purities of up to 99% can be achieved. Further processing steps can be utilized to remove additional material groups from this non-ferrous rest fraction. Inductive sensing by itself or in combination with other sensors is used to separate a cable or wire product with highest purities. These cable products can then be brought into specific processing lines in order to reclaim the copper. At this point, we are looking at the non-ferrous concentrate from the eddy current separator again. Using an X-ray transmission sorter, XSST, we are able to separate materials according to density. This system can be used to separate the light and heavy metals which are contained in non-ferrous concentrates from one another. The sensor image of an X-ray transmission system shows the material in a grayscale picture. The darker the objects appear, the more they absorb the radiation. At a certain level of absorption, the object qualifies as heavy metal. This is highlighted in the false color image below. The extraction of objects out of the material stream happens via compressed air bursts from a valve bar. The example shows the extraction of heavy metal objects out of a non-ferrous concentrate. The light metal product consists of numerous aluminium alloys and often contains small quantities of high alloyed magnesium. The heavy metal product mainly contains copper, brass, zinc and other heavy metals. These can be further separated using X-ray fluorescence. We will come back to this point at a later stage. X-ray transmission offers additional possibilities for efficient material processing. The light metal fraction, for example, can be further separated to generate a wrought and a cast aluminium concentrate. Furthermore, with some special adjustments to the detection, we can achieve a separation of free magnesium pieces of up to 97% to generate high-quality aluminium products.